Um, Today, we welcome Laura, who is currently a postdoctoral fellow at the Minnesota Institute for Urban Innovation at the University of Chicago and also at the Institute for Analytical Sociology at Linköping University in Sweden, where she was previously awarded her PhD in analytical sociology. Her work combines sociology, urban studies, and complexity science, particularly looking at how statistical information can be used to understand the mechanisms behind social inequality, social influence, and intergroup relations. And today she's going to be talking to us about cross-cutting neighbours, how preference regimes moderate the effect of consolidation on segregation. So with that, I'll pass over to you, Laura.
Thank you so much for that introduction, Catherine. Welcome everyone. It's nice to be here. Today, I'll be talking a bit about a project where we're taking a mechanism that is very established in the networks literature and trying to apply it to the study of segregation. So in particular, we'll be thinking and talking about how residential consolidation, uh, this idea that, or the extent to which the attributes in the population, like ethnicity and income, are correlated, shapes the emergence of segregation. This is joint work together with my colleague Martin Arvidsson, who's at the Institute for Analytical Sociology in Sweden. And I'm happy to take questions throughout the talk, and please let me know if anything is unclear. All right, so we're starting from something very familiar. It's this idea that people respond to who is around them when they choose where to live. When they move in or out, they change the composition of the neighborhood for everyone else, which then feeds back into the next round of choices for their former neighbors. This is established in a very seminal Schelling model, where Schelling showed that even very mild preferences for similar neighbors, so very low levels of homophily, can, through this feedback loop, tip a city or a theoretical grid into a highly segregated state. So just to illustrate this, I have a very simple two-step process. We have two different agents, they're blue and they're red. And in the first time step, this blue agent at the bottom left it evaluates its local composition, decides that there's too many red neighbors, decides to move, which then in the second step means for the blue agent at the bottom, this change in neighborhood, which was formerly homophilous enough, is now suddenly not homophilous anymore. And as a consequence of that initial move, the second blue agent also decides to relocate. So this is a very theoretical model, but we also have various empirical evidence for these tipping processes in real settings. This is not exclusionary to neighborhoods, but can also be applied to schools and workplaces and so on. The important aspect is that segregation can be modeled as a feedback process. So agents compare the local mix to their preferences. If they're unhappy, they move. And each move shifts the local environment for others, which can cause these cascades. So we have a highly kind of dynamic interdependence in these models. And then on the other hand, when we talk about segregation, we usually talk about it along one dimension. You just saw my example. We had two different colors. But now we usually then imagine a very simple map, like some neighborhoods are low income, some are immigrant, and so on. So we tend to think in these single categories. But in reality, people don't come with just one attribute, right? So we often study socioeconomic segregation, we study ethnic migration, ethnic segregation. But individuals have both, right? They have an income, they have an education, they have a migration background, a family situation, and so on. And neighborhoods bundle these characteristics together in very different ways. But most research out there, while perfectly valid, looks at segregation by income or ethnicity or these individual characteristics. However, we have a lot of evidence in a very long-standing research tradition that does show that residential segregation ties together or links together economic deprivation with racial segregation or socioeconomic disadvantages. So this is basically what the large literature on neighborhood effects highlights. And that's also why residential segregation matters, right? If individuals were sorted by race into different neighborhoods, and that had no implications for for inequality, we would be less concerned with the fact. So I want to focus on kind of pretty old sociological concepts that structurally take this into account, and then take inspiration from the network literature that helps us understand this multiplexity. So the idea that social attributes can be aligned is pretty old. We call this residential consolidation. It is the degree to which characteristics like ethnicity and income are correlated in space. High consolidation means that group boundaries line up. So being in a certain ethnic group also means living in, for instance, a poorer neighborhood. Low consolidation, on the other hand, means that the same overall inequality is spread out in a way that creates few of these group boundaries. And this is very old. This has been established by Peter Blau, but also relates back to Simmel and so on. And in this talk, we want to argue that understanding segregation requires moving beyond the single dimension and measure this in a multidimensional space. And of course, segregation research has talked about some of these aspects, especially in the US. Metropolitan areas with higher racial segregation usually also show much stronger income segregation, which tightens this coupling between neighborhood composition and exposure to poverty. We also know by work by Ann Owens, for instance, shows that when income segregation between school districts is larger, Black-white achievement gaps are also larger. And at the neighborhood scale, we see for Chicago that households overwhelmingly move between a very kind of narrow band of race-class combinations of neighborhoods. And there's very few cross-boundary moves that would change these entrenched hierarchies. And then most importantly, Elizabeth Brooks' analysis of residential mobility is especially central for our purpose here, where she uses agent-based models to calibrate that are calibrated to empirical PSID data, where she identifies that that there are three important population parameters. So between group income inequality, within group income inequality, and the relative group size. So this relates to the idea of consolidation, and her work establishes that consolidation is important as a structural parameter that shapes how these micro-level preferences scale up to macro-level segregation. However, in her work, she holds the preference structure to her particular empirical setting of US metropolitan areas, which leaves open a kind of central theoretical question. Where that leaves open if this correlation changes with different preference structures. And this is exactly where what we're studying. But I also want to clarify what we're not doing here. I want to clearly delineate our study of consolidation from this idea of intersectionality, which of course has done a lot of work and captures these different identities on a very individual level. So individuals having a certain gender, an age, race, or occupation. But what we're instead are interested in is consolidation on the macro level. So how are these properties correlated on the population scale? So if we have perfect correlation, every majority member would be, in our example here on the top right, also affluent, and every minority member would be poor. And if we reduce correlation between those attributes, we're basically populating the diagonal axis. So we are interested in how populating the off-diagonal, in this case, relates to our outcome of interest, which is segregation. But what are these macro outcomes? So when consolidation is weak, certain populations can contain more of these mixed agents, which introduces basically a new agent type. We know, especially from work in lots of in classical sociological theory, but then also increasingly in the study of friendship networks and diffusion processes, that consolidation matters because it shapes basically who encounters whom and under what social meanings. And this can shape diffusion processes that we tend to understand through aspects of homophily, for instance. So when race and class are highly consolidated, these group boundaries reinforce one another. And when consolidation is weak, populations can contain more of these mixed combinations that can bridge categories. And we argue here in this paper that we cannot understand these consequences of preferences that are so established in the segregation literature in isolation. Because the same behavioral tendencies that can have very different macro effects depending on how these attributes are consolidated in the population. So in the bottom right here, I have an example where instead of having just two different colors, we now also have different shapes. So we have affluency and poverty, or like the income status marked by shape, and then the group membership, so minority majority membership by the color. And now, depending on how these agents relate to each other, this changes if neighborhoods are stable or if they tip. And this is basically what we'll talk about today. So just to reiterate, the gap here is that preferences and consolidation shouldn't be studied in isolation, but in conjunction. Usually there's kind of two different streams where either research keeps a fixed preference structure that is calibrated to one context and then varies the level of consolidation. This is, for instance, work by Elizabeth Brooke, or varies the preferences but keeps the structural setup context fixed. And now drawing on this established literature, we argue that understanding segregation requires to think through preferences and consolidation together as a kind of coupled behavioral structural system. Because consolidation does not just add on to preferences, but it does condition how preference structures for multidimensional neighborhood combination can shape segregation patterns. Okay, what do we mean by that? So if instead of just having agents that have one certain category, but two, we have to think about it in kind of a bit of more complex way. And as I said, we postulate that it depends on the preference structure. So if we're imposing simple kind of homophily preferences, where either if agents share the same race or ethnicity with each other or have the same affluency or socioeconomic status, we could expect that by reducing the correlation between those attributes, so by introducing agents that are category intersecting, more individuals would see others as in-group. So for instance, on the top right here, we have this kind of preference matrix of an ego, and at the bottom, we show how they relate to another category. So here at the top, we have an affluent majority member. They do see affluent other majority members as in-group. They do see, see here on the right, you can, sorry, I just realized that I was on the wrong screen with my cursor. So at the top right, we have an affluent majority member. They see other affluent majority members as in-group. They also do see poor majority members as in-group, and they do see affluent minority members as in-group as well. So they have, with each of these other categories, they share at least one attribute, but then they have no overlap or no homophily that is overlapping with poor minority members. So this is basically how to read this preference matrix. And with this imposing this preference matrix, we would expect that the presence reduces flight behavior. So if we're looking at a group here at the bottom, the affluent majority member here on the right, for instance, would not have any, would not be kind of pressed to move out of that neighborhood because they're sharing affluency status with these minority members here at the bottom. And so that basically gives them enough similar neighbors to stay in their current neighborhood. So here we would expect that consolidation, with increasing consolidation, reducing consolidation would reduce also segregation. However, this is not what we find empirically, how individuals relate to each other. Instead, there's experimental but also survey work that finds that, for instance, whites in the US are more accepting to affluent Black neighbors than of poor Black neighbors, and that respondents across different racial groups respond to class composition um, differently. So preference embed something like a status hierarchy over outgroups, not just kind of a binary in and outgroup distinction. Um, which can then be translated into a status ordered system where agents react to different social markers like race or income in perceived status shifts, and not just in the similarity. So importantly, for instance, is that so this is kind of shown here in this assumed or theoretical preference matrix on the top right. So affluent majority members in our example here, for instance, have a strong negative preference for being close to poor minority members. On the other hand, affluent minority members have a strong preference um, for being close um, to affluent majority members. So this translating these preferences into a network structure would, for instance, mean that affluent majority members have a strong negative association towards poor minority members, but affluent minority members have a strong preference for being close to affluent majority members here at the top right. So this basically forms an open triad that becomes a closed triad with a negative feedback between these two groups that have nothing in common. And I will talk you through kind of the details of this cascade, but here we would expect that reducing consolidation would increase segregation. And how we get to that idea is basically that we're expecting something like a mobility cascade. So imagine a neighborhood that is populated predominantly by affluent majority members. We have an affluent minority member entering because they have this idea of having this like upwards thriving preference of moving into neighborhoods that are populated by affluent majority members. This is perfectly fine for all the affluent majority individuals who are already living in the neighborhood. But by the presence of this affluent minority member, this certain neighborhood can now become interesting also for poor minority members because there is some overlap between those two groups. And through bringing in additional poor minority members, this then triggers an exit from affluent majority members that now feel like this neighborhood doesn't correspond to their preferences anymore. So just to sum this up again, we assume these two different preference regimes of, on the one hand, this kind of flat homophily where there's no status hierarchy, and these categories intersecting individuals can basically buffer some of that tipping. Whereas if we're encoding status hierarchy, these groups become ranked and category intersecting agents can trigger exit through higher status agents. And in order to test this logic, we are building an agent-based model where we implement these dynamics in a kind of shelling style agent-based model. As I already mentioned, we encode two binary variables and vary their association, which is consolidation. So here we're talking about ethnicity and class, which then gives us the four types: affluent majority, poor majority, affluent minority, and poor minority. The basic idea is then that agents evaluate the neighborhood based on the composition, and we vary how individuals evaluate these neighborhoods through these preference regimes that differ in how agents relate to each other. And we then basically have this two-step residential choice process where agents who are dissatisfied select intermobility and then choose a residential, in the second step, choose a residential destination that provides an improvement of the utility. And then as an outcome, we measure the dissimilarity index, which is basically measured along the axis of ethnicity in our case. So measuring kind of ethnic segregation in space. And dissimilarity basically captures a 0 if it's completely integrated and 1 if it's completely segregated, and captures the proportion of the minority that would have to move to achieve perfect integration. And just because this is so crucial, I want to briefly talk you through this two-stage mobility process, where at the first stage, individuals select intermobility. And under homophily, this is very simple. That if there's enough neighbors of either overlapping characteristics, so of either of socioeconomic status or of ethnicity, that can be sufficient to satisfy their criteria. But then when we're adding this assumption of status hierarchy, this changes with a kind of type specific requirement. So different groups would need different compositions. So this is just to highlight that this cannot vary how individuals relate to their neighborhoods. And then in the second step, we let agents choose their destination by ranking acceptable neighborhoods, and they're basically choosing to move to the neighborhood that has the highest utility given their preference function. And this again is much simpler in the kind of homophily case, where under status hierarchy, different agents have different preferences for the neighborhood composition. Okay, so here now I'm showing you the results of this parameter suite, which shows which displays how segregation responds to weakening consolidation under the two suggested preference regimes. The horizontal axis here shows that the kind of realized correlation between ethnicity and class, which decreases from left to right, so perfect consolidation at 1 to independence at 0. The vertical axis shows the dissimilarity index for the ethnic dimension, which is normalized by its value under perfect consolidation at 1. So according to that, if dissimilarity relative to 1 is larger than 1, indicates that the proportional increase in segregation relative to the perfect consolidation baseline. And if dissimilarity is smaller than 1, it indicates a proportional decrease. We use this kind of odd proportional measure to allow us to examine the change in dissimilarity by correlation across these parameter configuration, because just by definition, we have different compositions of agents in each of those across different levels of consolidation. The error bars are 95% confidence intervals that are computed across the full set of simulations at each level of consolidation. Okay, so the colors of these two lines encode the two different preference regimes. And here in red, we have this kind of basic homophily assumption without any status ordering. And here we see that segregation declines systematically as consolidation weakens. And the dissimilarity index here, for instance, falls kind of monotonically and reaches approximately 0.4 at the lowest levels of consolidation. This pattern, or this line reflects what I had mentioned as the buffering role of these cross-cutting neighbors under these simple homophily preferences. So as consolidation decreases and affluent minority and poor majority individuals become more prevalent, these cross-cutting agents, so these category atypical agents, can provide a partial match that stabilize neighborhoods. So, as an example, an affluent majority residence that has an affluent minority neighbor in a mixed setting perceives this overlapping socioeconomic class position, which then become as a basis for acceptance, and this avoids the tipping of neighborhoods. So this dampens the kind of original postulated feedback loop by shelling. If we're now looking at the blue line, which is the preference regime that encodes status hierarchy, this produces a very different pattern. So rather than declining, we see that segregation actually increases as consolidation weakens. But this is a non-monotonic relationship. Instead, it peaks at these intermediate levels of correlation, so at around 0.4. At this peak, segregation is approximately 2.2 times the baseline from full consolidation. This increased, and here now we're starting to think through these kind of the mechanism that allows us to see. So next I want to show you the mechanism that shows us that creates this inverse U shape for the status preference regime. So here, as I had mentioned earlier, we assume this mobility cascade where by virtue of having affluent majority members having affluent minority members as their new neighbors, poor minorities follow them, which then triggers exit cascades. And so in our simulations, we basically try to capture this three-stage mobility cascade by observing this cascade mechanism directly by measuring the frequency of each of these stages at in a sequence. So here I'm showing you on the right hand, on the x-axis, the again the realized correlation, so the level of consolidation, and on the y-axis we report how the mean number of each of these mobility cascade events. So starting at the kind of dark orange line at the bottom, we're count the moves by affluent minority members into affluent majority neighborhoods. So what you see on the left hand in stage one. The yellow line then counts how many poor minority entries into neighborhoods that experience a recent affluent minority arrival within a window of 500 time steps. And then the purple line at the top counts the affluent majority departures from neighborhoods that experience the influx of poor minority members. And here we're basically seeing that two patterns stand out. So first, the prevalence of affluent minority members moving into affluent majority neighborhoods, which is stage one, increases linearly as consolidation weakens. So from 0 to under full consolidation. So this is the stage one line, the dark orange one. So this shows that there's a growing amount of affluent minority individuals available to enter these majority-dominated neighborhoods. Secondly, this kind of downstream effect or downstream stage shows that there's kind of a more pronounced, here we see like a more pronounced U shape. And the frequency of poor minority members following affluent minority members into these majority-dominated neighborhoods, which is stage two in our cascade, increases kind of sharply as we get from 1.0 to 0.5. So there we see the biggest jump. While in these in the last stage, so stage 3, we see these exits peaking around 0.4 decline before we find the decline towards 0. So we see this as a kind of mirroring of the observed levels of segregation in the overall macro outcome. And see this as a good indicator for the fact that consolidation can actually produce these kind of complex mobility cascades under a status ordered regime. Um, so just to sum up the results of the ABM for now, we do find that correlation or consolidation fundamentally affects segregation, but it critically depends on the preferences. If we're having these just simple homophily, these category intersecting agents can provide positive buffers and actually reduce segregation. While if we have category intersecting agents under status order preferences, we do see that they can actually take a different role and increase segregation. So this was all very theoretical. And in order to give this a bit of a kind of empirical anchoring, we turn to Swedish administrative data and measure to what extent we find these outline mobility cascades in empirical data. And instead of imposing these kind of binary assumptions of affluency and poor, we're looking at non-Western immigrants and compare them as minority members and compare them to individuals with two Swedish parents born in Sweden as majority members. But instead of looking at two different income groups, we impose, we're thinking about if their income is above the median and categorize them then as affluent. If it's below the median, we then categorize them as poor relative to the neighborhood that they're moving into. So we're basically looking at we're trying to capture if higher income majority members, if they're more tolerant to higher income ethnic minority members compared to lower income ethnic minority members. So we're trying to trace these empirical signatures, or we're trying to trace these mobility cascades in empirical data, but we're making some slightly more kind of nuanced assumptions. And here, this is a very simple model. We take all the neighborhoods where we observe individuals entering a neighborhood that have an above median income for that specific neighborhood, but are minority members, and then find a positive probability that there's a minority low income member that follows them in a specified time window. And then in the third step, we find a negative probability for a majority high income member to remain present in that neighborhood. So this is a very simple test to see if these mobility cascades are just in our theoretical model, or if they can actually take place in the real world. And here we do find that these directional effects mirror what we had outlined in these kind of theoretical mobility cascades. Okay, so to sum this up, what we do in this paper is we link this kind of old sociological work by Blau and colleagues on consolidation to Schelling type dynamics and debates around intergroup contact. If these inequalities are aligned within origin and space, we find consolidated cleavages between group. Here, we're contributing to this growing work in sociology that identifies how dynamics can be countervailing. So depending on assumptions, we find this cascade mechanisms, but this has very kind of specific assumptions built into it. Our argument in this paper builds on what Linda Zhao and Felix Garib, for instance, showed in their 2021 paper that highlights the effect of homophily on network inequality and how that flips under low versus high levels of consolidation. We extend their work by showing that preference regimes can condition whether consolidation strengthens or weakens residential segregation. I should also say that, of course, we're looking at ethnic and income segregation consolidation here, but this could be applied to, for instance, gender and occupations, or very different regimes. And we're making a very simplified assumption of how to measure consolidation. There could also be a much more complex way of capturing that through kind of distributional measures. But I think what we can do is we can point to the fact that social dynamics are often layered. and that we really need to think carefully not only about the mechanisms that drive these outcomes, but also how they can countervail or amplify each other in order to kind of think clearly about the macro outcomes of these micro behaviors. At the end, I just want to thank my co-author Martin, and please get in touch if you want to have any questions or if you want to discuss this any further. Thank you so much.
Thank you, Laura. That was very interesting. I personally have lots of questions, but I'm going to open up the chat and or feel free to unmute yourself if you've got any questions. We can do it. If there's none immediately, I might be cheeky and ask one of my own. Forgive me because I don't have much of a sociological background at all. But you spoke a bit about these four groups of affluent, poor, and majority minority. But then the dynamics was more between three of those groups. And I was wondering, do you consider how the fourth group plays a role in those dynamics as well, or is it?
Yeah. So they're present in our model. They're not excluded, but the driver is really this negative feedback between the agents at the top and at the bottom of the status hierarchy. So the affluent majority and the poor minority members, and they are forced to be, or they are driven to be co-present through these agents that affluent minority agents that pull in their co-ethnics who have a different socioeconomic status in our example. So we kind of simplified the visuals, and we're only looking at these three agent categories, but they're still present. And I think, yeah, maybe it would be good to show this a bit more clearly in the visuals as well. That there is actually four groups that we're talking about.
Okay, no, I don't. I think it just makes sense. I just wanted to say there's not this similar set of events that happens involving those poor majority. Yeah.
But this is basically driven by this preference regime that we, of course, it's a simulation, right? So it's the preference regime is we try to empirically base it in research that's been out there. And I mean, there's a lot of research, for instance, on these like white flight dynamics, or which relates or which is like an argument for building preferences matrices in a specific way. But really having this tendency of affluent minority members attempting to live in proximity to affluent majority members, and then having this negative preference or this aversion of majority members to live close to poor minority members. That is what is driving this mobility cascade.
Thank you. Does anyone else have any questions?
Hello, can I ask a question?
Of course.
Yeah, sir, I'm not entirely sure if I entirely grasp sort of like the details of the model, but I wonder about two things. So the first thing is that when you say, so there's a cascading effect, but it seems like the cascade or the preference attachment of one group to follow the other or one group to react to the entry of the others are asymmetric in a sense that it seems like there's a cleavage in terms of which of the, let's say, fault lines are more influential in terms of making or in terms of determine people's behavior. So that's one point. I'm not exactly sure if I'm understanding that correctly. The other part is that I wonder, so I mean, because you're talking about sort of like race and class, do you consider the effect to be different if we assume that the grid that are trying to occupy are limited resources? In a sense, you can think about in a region where there are, let's say there are housing restrictions or building restrictions, and there are only a certain number of apartments, which basically mean that when there's new entrant, then that will drive up the prices. And for people who want to stay closer to, let's say, the poor minorities, they may not be able to enter into that neighborhood. So that itself seemed to be another countervailing effect in this entire story. But I know that's not what you're focused on, but I wonder, like, what will be the dynamics look like if we think about that? The third part is that I wonder, like, do you think if you scale up this let's say this number of dimensions that people defer. So instead of thinking about that as a housing decision or as a segregation in urban cities, if you think about that as like online platforms where there are let's say, numerous, limited, let's say, infinite number of dimensions where people can differ. In that regard, does that dilute the message in the sense that if you think about the curse of dimensionality, once you have more differences than any single dimension, any single dimension doesn't matter as much?
Mm. Yeah, so here, of course, we're doing this in a. I'm going to start with your last question, or with your last point. So here, of course, we're being very simple. We have binary variables and only two. Uh, Linda Zhao and Felix Garib, they've shown in their network paper that theoretically we could model this along a multitude of dimensions. Um, and I think this is something to be tested out in a model. I haven't I haven't tried that in our simulation. How if there's a dilution, or like if the effect or these cascades become diluted. Um, and I mean, our argument here is that this would strongly depend on how agents relate to each other, depending on these additional dimensions, right? Um, so if there's just something like differential preferences depending on the other dimension that we're looking at. So as an example, if we would include age here in this example, um, I think that would certainly change the associations. And I mean, you suggested if it might become diluted, but um, to be honest, I don't know what that would look like. Um, and then to your second question about housing and kind of affordability or access to certain neighborhoods, um, this is something we discussed a lot and we talked about, and I do think that we would hear, for instance, if certain poor minority members wouldn't even have access to kind of gentrified high income neighborhoods, we would just not see any of these cascades, right? Like the process would basically be stalled if we're already having a very segregated environment, and that doesn't allow poor minority members to access certain neighborhoods. Um, so I don't think our this mechanism will play out at the fringes of the distributions, where we have very poor neighborhoods that are highly racially or ethnically segregated, and very rich neighborhoods that only have majority members in them. But I do think we can potentially see these processes taking place in cases where kind of more in the middle of the distribution. And this is why, for the empirical part of the study, we looked at does it does a minority member that moves into an affluent majority member neighborhood, are they below or above the median, instead of taking into account the full distribution and splitting the whole population into two different categories. So I think this cascade mechanism is much more applicable for kind of neighborhoods that are anyway in flux and in the middle, and it, we have indication that it might take place in the real world empirically, and that will more so relate to does the tip in which direction does the neighborhood tip. But if it's already completely segregated in one way or the other, I don't think this mechanism will be very relevant. And then can you remind me of your first question?
Oh, so I think the first question is probably just because I probably didn't fully grasp what you mean by the preference hierarchies or status
Mm,
hierarchies, in the
yes.
sense that, so it seems like there's a sequence in terms of which, like, let's say there's a sequence of how the mobility will happen, and the triggering point happens in the sense that there are some members who react more strongly to some changes in the
Mhm.
neighborhood.
Yes. Yeah. So the preference, basically, the second part, which is the more kind of dynamic, interesting preference regime, where we encode a status difference between these four agent groups. Um, the most relevant preferences are that affluent majority members have an aversion to living close to poor minority members,
Okay,
um,
I see.
whereas these two agent groups that are in the lower parts of the status hierarchy, they have a tendency to thrive upwards along the status
Mhm.
hierarchy. So they seek out kind of taking a step up, in either in terms of affluency or in terms of group membership. So
I
that's
see, I
the
see.
yeah.
Yeah, cool. Thank you so much.
Thank you for your questions.
Are there any more questions from anyone listening? If you don't want to unmute yourself, please feel free to put it in the chat as well. For fear of turning this into Catherine's sociology lesson, I do have another one of us, if no one
Of
else is going
course.
to jump in. I think it was just my understanding as you were speaking, but on some of the graphs to do with the number of events, it goes up and then it goes down.
Yes.
Could you give me a bit of intuition as to why it goes back down again after it starts to increase?
So you mean this particular
Yes.
slide here, right? Yeah. So here if we have very low levels of consolidation, we basically we have very few dynamics occurring. So there's so if at the left we have perfect correlation. So there's none of these kind of category intersecting agents. So there's no affluent majority member, there's no poor minority member on the left side here. So this is why there's it's at zero at this stage. So there's just no dynamic. There's nothing happening. And then as we get to very high levels of or very low levels of correlation between those two different groups, we see that these kind of attenuation of these later stages are very low at low, which accounts for this what we see. What we see in this case, right? We see this inverse U shape where with low levels of consolidation, we see the kind of curve going back down in the status regime. So this is being mirrored here in this case. And this is basically that there's the composition of agents changes depending on the level of consolidation. That's the whole point of this exercise. But if we get to these kind of fringe cases, there's just enough other neighborhoods that would facilitate satisfaction for these agents, which then means that there's fewer dynamics that are taking place. So as the composition of agents changes by the virtue of consolidation, we see that there's a decrease in this in these mobility behaviors of agents. I don't know if I was very clear now.
No, that makes a lot of sense. Thank you.
Okay.
Any final questions from the chat?
If there are no more questions, I just want to say thank you for having me in the seminar and also for all the questions and I'm happy to chat a bit more, but I don't want to keep everyone else in the room.
No, I think that sounds good if all the questions. So thank you very much for presenting. It was a really interesting talk and I really enjoyed it and I'm sure everyone else in the chat did as well. We'll let everyone get back to their evenings in that case.
Perfect. Enjoy the rest of your day. Thank you for having me.
Thank you.
Bye, everyone.
Thank you. Bye.